We won't get into college if we can't do calculus.
I'm getting so frustrated. I wish someone would come help us.
Do I hear someone pushing calculator buttons?
Oh, hi, Math Man.
That's right, girls. It's me, Math Man, here to save the day. Let's get started with math. Yay! First, we need to understand the basics. This is assuming that both limits exist.
Wow, that looks really difficult. I don't think I'll ever understand it.
Maybe I should call in some more help.
Limit lady here. Oh, hi, Math Man.
I need your help. I have 2 struggling math students.
Okay, no problem. I'm on my way. Limit lady here, reporting for duty. Let me see if I can help. Now, this describes the IROC, or instantaneous rate of change. And it finds, say we want to find the tangent of this point right here. We want to make it as close to this, we want to make this point as close to this point as we possibly can to make them virtually on top of each other so that we can find the tangent right here. So in order to do that, we want to make h as close to 0 as possible. So we put this limit in right here and make h approaching 0 so that we can find the derivative. Have you ever been walking down the street and someone's like, hey, what's the derivative of x squared? Well, if that ever has happened to you, I can tell you how to solve that. But first, we're going to remember our handy-dandy definition of the limit derivative. Remember that? I just taught you how to do it. So now we're going to actually apply this. Okay, so we're going to apply, so we basically just applied the x squared into this little doodad right here. X plus h squared minus x squared all over h. We're going to solve this a little algebraically. Put our algebra hats on so that we have this. Don't forget to write your limit as h approaches 0. Sorry if you can't really see that. Plus 2xh plus h squared minus x squared all over h. And so these two we're going to cancel on out of there, and then we're going to pop these h's out. So we've got 2x plus h. And since h is approaching 0, that's not there, it's 0. And our answer is going to be 2x.
Okay, so we're going to solve this limit using the substitution method. So simply all you're going to do is plug in this 3 for x. Six minus 3, therefore the limit as x approaches 3 is simply 3. So now you may ask, what if the function is not continuous? Well, first, I'm going to solve algebraically. These factors, x minus 2, x plus 2. And you're going to cancel out x minus 2. Then you can solve algebraically by just simply plugging in 2 for the x to get 4. And the limit does exist because the limit approaches 4 from the left and the right. However, there's a POD at x equals 2. So now we're going to find the limit of this function at x equals 1. So we have the function x cubed minus 1 all over x minus 1. So using a table, or you could use your graph and your calculator, we're going to examine the behavior of the function at x equals 1. So we're going to take values that are very close on the left and the right of x equals 1. So we're going to use 0.999, 0.99, and on the right side 1.001, 1.01. So when you use your calculator and plug these values into that function, you will find that the f of x is 2.97, 2.99, and on the right side 3.03. So as you examine these behaviors, you can see that from the left-hand side and the right-hand side, the limit as x approaches 1 is equal to 3.
I get it!
Thank you, Math Man and Limit Lady. Now I really understand limits.
No problem.
That's what we're here for.